Welcome everybody. Thank you for joining our webinar today, Next Gen S3 Compatible Object Storage, the journey to an AI-ready data lake. And joining us today are Adam Dagnall, Senior SE Director for EMEA, and Halvor Evensen, Regional Sales Manager for the Nordics. Welcome, Adam, Halvor.
Welcome, guys. Thanks for joining. I'll just do a quick introduction and then and hand it over to Halvor for a couple of slides. So my name's Adam Dagnall. I'm the Senior Sales Engineering Director for EMEA. Been working with Cloudian for nearly 9 years now, and I'll be walking you guys through the bulk of the content today. Thank you.
Yeah, hello everyone. So my name is Halvor Evensen. I'm the sales director for Nordics and Baltic region. Yeah, currently based in Oslo, Norway. Yeah. Yeah, so just a short recap. We might have some new ones on the webinar today. So just a short recap of kind of Cloudian and who we are as a company. So Cloudian is basically, running AWS S3 in your own data center, right? So we have a software-defined storage that you put on top of your commodity x86 hardware platform. It could be, whatever. And what we do is that we're actually enabling, multiple use cases for enterprises today. And the S3 space are really changing, and that is what really this call is, all about today. We in terms of security, like I said, security, it's in core of everything we do at Cloudian. And we will also, get back to that. I'm sure some of you know kind of our security tour today already. Of course, scalability, we will touch on that, but one of the big advantages with object storage is, of course, how you can actually scale. And, S3 is built in the cloud. We all know technologies like iCloud, OneDrive, Dropbox, etc. And they all have one thing in common, right? It's how they can actually scale and deliver services. Yeah, so we basically also have a feature-rich for shared cloud platforms. We also gonna go a bit more into how you actually can use our services on-prem, but also how you can actually tier and replicate natively to the cloud as well. In terms of use cases, we have everything from VMware to backup vendors, all of these. But today the primary focus is a bit more about finding new use cases, and we see a kind of a big shift over to the data analytics and AI space. And then just short, we're also the AWS Outpost and local zone partners. So if you need services on-prem today and you're on the Outpost program, Cloudian is the standard there as well. In terms of segment verticals, where do Cloudian operate today? We have everything from Formula One cars all the way to governments, to healthcare, service providers, media and entertainment. We have some big retail customers. So we're basically operating in all the verticals today. So yeah. And then just to kind of set the scene in terms of where we are, and Adam will get back to this in his presentation, but we see a clear shift from kind of right to left, where typically we've been very strategic with our backup and archive type of use cases. But we now see a clear shift over to the left, where you have these more modern applications that are actually, preferring S3 over these traditional storage architectures. And Cloudian really sets the ground here in terms of, being able to support both traditional, but also all the modern applications that are racing in this field. So yeah. So that's, I think, a good introduction to Adam.
That's great. Thank you, Halvor. Appreciate that. It's good intro. Before we kind of get into the main sort of theme of this presentation, I'm just going to kind of go over a couple of slides really about our architecture and some of our design principles, because at the core of what we do, I think these three tenets are really key. So scalability, you know, we're basically a software defined scale out object storage platform that can scale into, you know, hundreds of petabytes, exabytes, you know, virtually without limit. And as we do that, as we scale the system out, not only can we realize more performance, but we're actually able to take advantage of, you know, additional protection schemes. You may start off with, say, a single site deployment and then add an additional DC or a logical DC, and then that lets you protect the data in different ways, and that's kind of unique to us. Security is a massive focus, you know, in terms of our heritage, as Halber says, you know, backup and archive has really been kind of the foundation from where we've come from. And we've worked, you know, over the last couple of years to ensure that we have a very secure platform. You know, our alliance with Veeam has, you know, allowed us to go after, you know, customers that are looking for ransomware protection, which is obviously incredibly hot at the moment. And the way that we do that is through Object Lock, which is part of the AWS S3 standard, and also by actually hardening our appliances as well through something we call Hyperstore Secure Shell. And then the final kind of design principle or tenet here is S3 compatibility. And I think it's fair to say we offer the most complete and extensive support of the S3 standard outside of AWS. And there's a lot to it, as well, as you'll see as we go through this presentation. In terms of how you can consume our stuff, there's a couple of different ways. You can either buy hardware from us. We have our own appliances. We have a few different models here. We have a 1U box. We have a couple of different 4U boxes. We have flash appliances as well. So really, depending on what you're looking to do, really dictates the type of architecture you use. But you don't have to use our stuff. If you want to, you know, roll your own, so to speak, you can deploy on any, you know, any hardware, Dell, HP, Lenovo, doesn't really matter. You can actually run our stuff as VMs, which is great for proof of concepts. It's great for test dev environments. And you can also run our stuff in the public cloud as well. So it's all about flexibility. And, you know, because we are software defined, it really allows you to do really anything you want to within reason, of course. In terms of our product family, there's only really a few things that we sell. I mean, Hyperstore is really our core offering. It's the scale out S3 object storage platform. We're just in the process of fully releasing Hyperstore file services, which will allow us to present out SMB and NFS. Of course, a huge caveat here is this is really a NAS interface into an object storage platform. It's not a NAS, so to speak. So we have to be careful about the different workloads that we put on top of this. But as you'll see as we move through the presentation, actually with some of the more modern workflows, you know, the machine learning, the AI, actually file services, and some of our integration with AWS Mount Point actually lends itself very well to those kind of use cases. And then over on the right hand side of this slide, we've got HyperBalance, which is a load balancing solution. The way that object storage platforms work is, you know, all the data goes over HTTP or HTTPS, and we need to distribute the load across the node. So having a load balancing solution is important. Some customers have load balancers, some don't. So we have this in our portfolio to effectively plug that gap if customers don't. And then the final thing to talk about here is HyperIQ, which is really a, you know, reporting tool. There's some analytics in there, you know, descriptive analytics of how the system is being used, allows you to go back in time, look at various different metrics, and as you'll see, where we're working towards is actually really being able to leverage some of that information and actually automate actions on the back of it. So kind of the AI ops type workflows, which are coming. Today, it's really just an observability platform, but we'll see a lot more rich functionality coming out of HyperIQ in the future. And I'll go over this quickly. I mean, I've covered some of it off already. You know, flexibility is really core. Being able to run as hardware or software on different appliances, different hardware options, allows us to do a lot of different stuff. We're also very flexible in terms of how you grow the system out. You can actually grow the cluster out one node at a time. So very kind of granular building blocks. And it's a true peer-to-peer mesh. If you zoom in on one of the nodes and actually look at what's running, they're all doing the same thing. They all run our distributed database, which we keep the metadata in. They're all able to service S3 requests. They all have storage. So, we don't have the traditional bottlenecks that you might associate with other architectures where, you have some devices which are there delivering, front-end connectivity. Other devices are configuring storage, and you can end up with bottlenecks in different places. The way we're designed is very elegant, and as you scale it out, you're able to not only take advantage of more capacity, but drive more performance as well. Multi-tenancy is also a big kind of play for us, and something that's kind of difficult to bolt on retrospectively. We've had this from day one. So there's a lot to it. We've got role-based access control, there's IAM, which is part of S3, there's quality of service, there's LDAP, chargeback, and as I say, this is been designed from the beginning to operate in multi-tenant environments. So, great for service providers, but also good when you're, looking at having multiple use cases on the same system. And as we kind of get into this some more, you'll see we kind of start with backup and archive, and very often we lead into additional use cases, especially when we see this kind of movement in the market where, over the last 12-18 months, this whole data lakehouse ecosystem has really exploded, and you'll see we've got a number of different integration points with these new applications, and it means we need to think about how we design the systems in slightly different ways as well, and I'll come on to that in a bit more depth. So scalability, we support up to 200 nodes per region and 20 regions in the system. So that's a lot of nodes, probably more than any environment is ever really going to need, certainly in the enterprise space, I would say. But we start also at a fairly low entry point as well. So our minimum deployment is 3 nodes, and with our 1U boxes with 12 terabyte drives, that's just over 100 terabytes of usable capacity. So we can go from 100 terabytes right up to potentially 3 exabytes of raw storage, and we can do that in a non-disruptive way. And that's one of the key differences between something that's scale up and something that's scale out. With a scale up system, once you've filled it up and you've reached the limits of expansion, you effectively have to buy the next one, the next series, the bigger bear, if you like, and then you have to migrate your data. And of course, migrating data is risky, introduces downtime, and it's not really well suited to archive use cases, long-term retention, compliance. It's difficult to meet those challenges when you have to keep shipping your data around. So being able to have a system that you can evolve over time without having to move your data is in itself a differentiator. A slide here on S3. S3 is a complex beast. There's probably about 120, 130 API calls since I last updated this deck, and we support most of them. There's some we don't support by design. There's some we don't support because we haven't got around to it yet, like S3 Select. And it's really driven by what the market is asking for. If we had lots and lots of customers knocking at our door asking for S3 Select, we would make it a priority. But actually, what we focus on is really the core functionality and doing it in a native way. So again, to compare and contrast us to some of the other platforms that are out there that run their own proprietary API that support maybe S3 and Swift and other object protocols, they have to go through this translation process, and of course that in itself can be a bottleneck, and stuff can get lost in translation. So one of the early bets that Cloudian made was to effectively bet the farm on S3 when we launched back in 2011, and it's the only thing we've ever done. So we're very proud of our S3 compatibility. Things like multi-part upload, versioning, tiering, you know, they've been with us, you know, since our inception, and you know, it's tried, tested, battle tested, and works really well. So security is another, I mentioned before, key focus area for us, and there's a few areas we play into. So there's the data immutability piece, which is really, you know, we mimic the functionality of S3, AWS S3 object lock. We do it in exactly the same way. We can run in a compatible mode or a compliant mode. And if you're running in the compliant mode, that means you can adhere to the security certifications, you know, the FIPS 140-2, the Sarbanes-Oxley 17-8A4 standard. So if you need the you know, compliant security rubber stamp validation, then you know, we provide the platform for that. And then of course you can take advantage of that inside your environment. Multi-tenancy plays into the security aspect as well, and then of course data encryption. And when we talk about data encryption, like with S3 Object Lock, we do it exactly the same way as AWS. So we support server-side encryption using AES 256-bit, and then for data in flight, we secure the data effectively over HTTPS. There are a couple of other things we can do with encryption. We support key management systems as well, but you know, there's just for, you know, most customers that want to encrypt their data, they can tick a box when they create a storage policy, and that means all of the objects that are you know, created within that bucket are automatically encrypted using server-side encryption. So I'm going to flip gears a little bit now. That's kind of the, you know, the warm up, if you like, a little bit around, you know, Cloudian and how we work, and really sort of want to talk about how, you know, certainly things have changed in my tenure at Cloudian over the last 9 or so years. You know, very much at the beginning, I spent a lot of my time actually telling people what S3 was, because it was new. You know, it wasn't necessarily something that was on everybody's shopping list. And then, you know, maybe about 2 years into my time at Cloudian, people started buying it, but specifically for backup, you know, and we had a lot of success with Commvault, Veritas, Rubrik, you know, was certainly a real key alliance partner for us, and still to this day we do a lot with Rubrik, and then Veeam came to the table, and you know, we really kind of got on the whole, you know, ransomware bandwagon, and had some great success there. But over the last few years, 2-3 years, 18 months, it's certainly intensifying. We're starting to see a shift towards some sort of newer and, you know, more exciting, quite frankly, use cases. So backup itself, you know, is pretty standard stuff. And actually, if you look at, just to zoom in a bit on S3, it does a lot more than just read write, which is kind of all you need for backup. You know, backup just needs the ability to write data when you're doing the backup and read data when you're doing the restoration. But S3 has a whole load of stuff that's layered on top of it. So things like encryption and tiering and replication, these are all built into that, you know, S3 standard, which is REST based. And of course, any application that can take advantage of HTTP or HTTPS can take advantage of these storage platforms, which has really driven, in my opinion, the whole you know, cloud compute story, right? You know, if it's a watch or a toaster or a fridge, if it talks HTTP or HTTPS, it can use this. The Internet of Things is another great example of what's driving the, you know, the consumption on cloud. But anyway, I digress. So, you know, our S3 runs in a distributed environment. You know, it's a single namespace typically, you know, S3 yourdomain.com. And one of the things you have to understand about object storage, you know, generally, not just Cloudian, is operations that would be, say, fairly simple on a NAS or a SAN, like deleting a file, are actually a lot more complicated in an object storage environment. You know, we have to delete the metadata, we have to delete across all of the nodes. You know, if a node is off for whatever reason, we need to make sure when that node comes back online that, you know, it's got some data that it needs to delete. And this just adds additional processes and additional work to the system, and something that we need to be mindful of. And actually, we started to sort of become more mindful of this with Veeam, because Veeam actually is a use case that uses very small objects sometimes, and when you delete, we need to make sure we can delete enough objects within a certain time frame. So something we started thinking about, when maybe 2 or 3 years ago, and actually now as we move towards these more modern workflows, the sort of data lakehouse stuff and AI and ML, actually we need to be mindful of this, but also performance and other metrics as well. So kind of just a word of caution here. Now, this slide is an interesting one, because it's kind of the heritage side. We've always been the storage platform for the unstructured data, which is typically anywhere between 80 and 90% of any organization's data is the unstructured static data, with 10-20% of it being the fast transactional stuff, which has usually been satisfied by block and file. But actually what we're seeing now is we're actually seeing a shift over to object being used as the primary storage tier. So where we come from is this slide here, so large data sets, backup, archive being a secondary storage tier, tertiary tier, customers that were looking for worm that then became object lock, then driving that whole ransomware piece, long-term retention, and ultimately the biggest point is the one at the bottom there, cost optimized capacity, cheap and deep, if you like. That's where object storage has always traditionally been. But what we're starting to see is a shift. And yeah, I'm just gonna skip over this use case slide here. You will get a PDF print out of this, so you can go over the use cases here. We will zoom in on them, but we're starting to see a shift to two kind of areas here. The first is cyber storage, which in itself is kind of a cool term, and I actually put into ChatGPT what is cyber storage, and this is the answer that it gave me. Again, I'm not going to read it out. You can study it at your leisure, but it's effectively what we've been doing since our inception in 2011. But actually what's interesting is NIST has developed a cybersecurity framework based on cyber storage, and it really kind of rolls into these 5 key areas, which is identify, protect, detect, respond, and recover. And actually today we kind of meet 3 of those key areas in terms of identify, protect, and detect. And within our roadmap, we are working towards respond and recover. And this is really around the hyper IQ, being able to detect anonymous access in your environment, perhaps users that shouldn't be accessing certain buckets, or IPs that shouldn't be accessing certain resources can get flagged, and then we can perform actions on that, maybe object lock the bucket or whatever it might be. So yeah, this is kind of an area that we're working towards, and kind of an interesting theme. But where I thought the slides were going was here. This is kind of where we're moving towards as object as primary, and there is a lot of hype around this. And we have to be cautious around how we design these systems, but ultimately what we're moving towards is the primary data set being held in the object store, rather than us being a second or a third copy of the data. Just like everything in our world, it's all application driven. There's the data lakehouse workloads, which we'll spend a bit of time talking about today. Analytics, machine learning, and artificial intelligence, and all of these areas are poised for huge growth over the coming months and years. So certainly an area we need to be paying attention to. We have some tools at our disposal in terms of how we can prepare ourselves for these workloads. As I've mentioned, flexibility is key, and we can deploy our software on high performance nodes, flash nodes, that give us, a lot more I/O than, the traditional HDDs that we know and love. We have the option to create hybrid storage policies so that if we're storing very small objects, we store them as replicas, and the larger objects get stored as erasure-coded objects. This reduces the pressure on the system at the cost of capacity. But, this is a nice feature to have if we don't know exactly what's going to be in a bucket, or we know that the data that's coming into the bucket is going to be a mixed bag. This allows us to ensure that the data is storing the system is storing the data in the most efficient and effective way. And the final piece here is adaptive bucket rules, which is again something that we're getting better at. And this is really tuning our metadata database for the data that's in the bucket. Is the one sentence boiled down summary of what that does. And it's really just looking at the data structure and then changing the way that we kind of partition the data within Cassandra, which is our metadata database. And what does this mean? I mean, ultimately, it means you're eliminating redundant copies of data, right? So if you have the traditional, let's say you've got a file server and you store your data on your NetApp file server, which is great, and then you back that up to tape using Commvault. You've got the 2 copies of the data. The nirvana here is if you have enough redundancy in your platform to protect you against hardware failure and site failure, so you can lose a site and you can lose hardware at the surviving site, that's giving you the physical protection of disaster. And if you have the software within the platform to roll back to previous points in time, like you would do with a traditional backup and, tape media or VTLs or whatever, then actually there's an argument here that you can eliminate backup from the environment and actually, save yourself a whole load of CapEx and OpEx on that. So, that's kind of, I think where we're moving towards. The data lake house, this is the AI definition of what the data lake house is, and this is a graphic that was created also using AI. But this is just an area of massive growth, right? And I've got 8-10 examples on this slide. Again, you'll get a PDF so you can have a look at what all these different ISVs do. But Splunk's one that they introduced support for S3 maybe 4 years ago, perhaps even longer. And really, it's taken some time for customers to kind of warm to this and start using it in anger. And really what it does, it allows you to decouple the the compute from the storage. Traditionally, before Splunk had Smart Store, if you needed more capacity, you needed more indexes, and indexes are expensive, so it's very costly. Now, being able to decouple the storage from the compute means you can right size. You can have the required CPU memory for the indexes and keep all of that warm data in S3. It's there if you need it. It's it just pulls it out if required, and that can grow, and that data effectively can live on the the high density disks, right? You can live on the cost optimized storage capacity. This is a great model. However, we look at something like Microsoft SQL Server 2022. This is the real kind of data lakehouse workload here, because we've got well, there's 2 parts of Microsoft SQL integration. First is backup, being able to use native transact SQL commands to back up a database to an S3 bucket. Works really well with SQL Server 2022. Lots of options. You can have it parallel streaming and really kind of flood it in terms of performance. And of course, great for recovery as well. But the other side of it is actually being able to store and manipulate and work with data sets that are stored in an S3 bucket. And there's various different formats that are supported. It could be JSON, could be CSV, could be Parquet. But the idea here is you can actually manipulate that data. You can run queries against the data. And again, what does this mean? It means I'm decoupling my storage and my compute and making them separate. But of course, I do have to be mindful here that if I'm storing, lots of small objects on my my S3 bucket, or I'm storing, billions of Parquet files, then I need to make sure that the S3 platform that's underpinning it has enough resources for those, for those workloads. So again, looking at something like Flash, looking at those hybrid policies, potentially adaptive bucket rules. But yeah, lots of noise, lots of excitement in this area. Very different model to what we've seen historically. I put an example here around machine learning. We have a large customer out in Norway. I'm not going to name drop them, but they have a machine learning use case with us, and I thought it was quite an interesting one, and I wanted to share. So they have a lot of text and image files that are archived and then referenced, and they're in the process of actually digitizing these assets really as quickly as is humanly possible. This is a human process where they're digitizing these assets, and they copy them over to an S3 bucket that's running on Hyperstore. Then a OCR process that is running in a containerized environment runs against these assets. So we're looking effectively at images and PDFs. And that process basically creates XML files that are then stored in the bucket along with the assets. So if it's a picture of a beach, for example, this OCR process will come along, it will look at the picture, it will identify keywords that are associated with the image, so perhaps the sea, the sun, the sand, sandcastle, whatever it might be, and it will create an XML file and then basically stick it in the bucket along with the asset. So it does that for both text, which is kind of easy to do because it's just text conversion, and then the sort of machine learning piece, if you like, is the image file identification, which is kind of similar to the way that media asset managers work and other use cases that we've seen in the past. The thing that makes this use case kind of interesting and exciting is the fact that that's not the end of the workflow. Then Elasticsearch comes along and it actually reads all of these XML files and indexes them so that users or applications, without giving the game away, can come along, hit a search bar on the organization's website and say, show me a picture of a beach. I'll pull out all of the images and all of the PDF, all the text documents that have any reference to the words beach. Now, looking at this workflow compared to our traditional backup, where we have this kind of churn rate, it's very different. We do a write, we then read the data, we then write some more data, we then read the data again, and then we keep indefinitely. So, if we know the IO pattern is going to be different, if it's got a different IO fingerprint, then we need to again size the system accordingly. Actually, this is a great use case for us because it's not particularly transactional, and actually a really good use case for us. So shifting gears here, AI, we're starting to see a lot more, again, hype, interest, buzz around AI workloads. We've got some integration points with PyTorch, also with TensorFlow through the AWS Mount Point. And I went into ChatGPT as well, again, because I'm lazy, and said, what are the main features that, object storage bring when we talk about AI workloads? And according to AI itself, these are the themes. So scalability, cost, accessibility, versioning, pre-processing, model serving, and compliance. And again, we kind of tick all of these boxes. I guess one area where, we don't necessarily do anything too much natively is the pre-processing side, but going back to the previous slide and the way that workflow comes together, there's pre-processing there, but it's not actually done by Hyperstore itself. So I think the point I'm trying to make here is object storage itself lends itself very well to these type of use cases. And I went back and, again, incredibly lazy, I asked ChatGPT what specific applications would use S3 for deep learning, and here are some of the examples here. And again, some of the the sales cycles we're getting involved with, the opportunities that are getting brought to the table, we're seeing more and more of this stuff all of the time, which is great. Again, I'm not going to read it all out. You can have a look at this at your leisure. Kind of final part here, you know, the data platform is really the foundation of AI. You know, it's an integrated set of technologies. And if you look at what we do, right, I mean, we are an integrated set of technologies. We've got our S3 object storage platform, you know, the core of what we do, Hyper IQ piece that sits on top that gives us that observability and will lead us into these kind of AI ops workflows. We've got the file services for Hyperstore, which is, you know, going to be battle ready very, very shortly, which gives us the S3, NFS, and SMB, which kind of leads us into you know, the TensorFlow workflows with AWS Mount Point, and Hypersearch, which is something that again, it's a bit of a future for us, probably 6 to 12 months out. This is really extending our capabilities around metadata search and index. So final slide here, you know, in terms of AI, at least, you know, where do we meet the requirements? Scalability, you know, limitlessly scalable and modular, you know, modular and scalable. I know there are a couple of terms that get bandied around a lot in the industry, but we truly are. Data governance and security. So we have the certifications, we have the immutability piece. This is something we have, you know, it's tried and tested. We are a performant, you know, play. I know I talk and I mentioned earlier on that, you know, we're very often cost optimized, but there is a shift, right? You know, if we're going to be going after these modern workloads, the data lakehouse, the AI, the ML, then, you know, we need to adapt, and these are typically more transactional. So we're going to be looking at, you know, Flash-based architectures over the, you know, the traditional, or a combination of the two. But one of the things we do have, and we've always had, is the ability to, you know, do parallel processing, and, you know, as you add nodes, you're able to deliver more performance, and it's typically the network that becomes the bottleneck. And finally, and this again comes back to you know, the flexibility piece. We integrate with the cloud, you know, whether that's tiering, replicating data, or even running in the cloud. You know, we can do this today. So, you know, you're not necessarily locked in. When we store data in a bucket, it's always in its native format. If you're storing data in file services for Hyperstore and it's stored in as image, when that data is moved to the bucket, it remains as an image. So we don't change it. We don't lock you into any kind of proprietary format. If you move data to the cloud, again, it's in its native format. So it's all about having that flexibility and being able to change your platform over time as your requirements change. So yeah, that brings me to the end of the slides. If there's any questions that have come up through the session, please let me know. I don't have the chat window open, so
yeah, Adam, I have 2 questions that came in.
okay.
The first question is, what is the entry point in terms of capacity?
So yes, in terms of capacity, as I mentioned, it's probably around 100, 150 terabytes. That's the same for both Flash and the traditional hard disk based appliances. And when we talk about those entry points, really what we're offering here is a 3-node cluster. This is, you know, the bare minimum you can deploy in production. So that would be normally our 1U boxes, either Flash or HDD, 12 drives in each. And what we would do in terms of a protection scheme is an RF3. So we make 3 copies of the data. Each node gets a copy. Not necessarily the most efficient way of doing things, because it's, you know, got a 3x overhead or only 33% efficient. So if you're looking to, you know, kind of get the most bang for your buck, if you like, a 5-node deployment would probably be preferable, because that will allow you to do erasure coding 3+2, which is actually 60% efficient. So you go from, you know, about 100 terabytes usable with 3 nodes to, you know, about 300 terabytes usable with a 5-node cluster. So a lot more efficient in terms of cost per gig.
Perfect. And the other question is, do these modern applications always require Flash?
Good question. So no, not always. So again, to look at the Splunk example, Splunk has a favorable object size for us. It really all comes down to how the application writes into object storage. And I think, any object storage platform, we all kind of suffer from the same challenges, and it's around deletions and garbage collections and really background tasks, rebalances, that kind of stuff. And if you have a lot of small objects, and I'm talking billions of small objects, then that puts pressure on a hard disk based system. So really, when you're talking about 5+ billion objects, Flash is really the only way to go. However, if you're using something that plays nicely with object, it's got big object sizes, then absolutely a hard disk-based system is the way to go. And of course, with Splunk, that's a great way of doing things. Even with the SQL, reference that I mentioned earlier, in terms of backup, hard disk is absolutely fine. And then it really depends on what your specific use case is. What type of data are you storing in SQL that you want to access via a bucket? How big are those Parquet files? If we're talking about 20 meg files, absolutely great. If they're kilobytes, then then we'll probably have to look at some different architectures. So I know it's the most IT answer you could ever give, but it really is it depends answer.
Thank you. Well, that's all we have for today. If we didn't answer your question, we will follow up and to make sure that your question will be answered. As mentioned, we will send over the slides as a PDF so you can go over them. And if you have any questions, either reach out to Halfor or to Exclusive Networks Sweden. And well, thank you again for joining us today.
Thanks, everyone.
Thank you, guys.